In the second half of example 7, we've got tangent x that we have to do the Maclaurin treatment to, or at least the first 3 non-zero terms. So this is another example that you certainly don't want to just take a whole bunch of derivatives of. Well, just think about the derivative of tangent. Derivative of tangent is secant squared. All right, that's fine. But now you got to take the second derivative. And in order to take the second derivative, you have to use the chain rule. Leapfrog that 2 down, 2 times secant to the first power times the derivative of secant, which is secant tangent. And then all of a sudden on your third derivative, you have to use both the chain rule and the product rule. No, absolutely not. So there's got to be an easier way, and there is. So it's sort of like what we did back here on this one, where this one was, a whole bunch of multiplication. We just multiplied this guy times these terms. Do the same thing with tangent, except for not multiplication, because tangent is sine divided by cosine, I'm pretty sure. So we will just do some division this time. Now, it doesn't make sense to do term by term division, because that's not the way division works. Instead, we're going to divide all of these into all of those by polynomial long division. You know, that thing that you learned how to do back in Algebra 2, finally coming into play. Well, actually, I guess it didn't just finally come into play. Here's another use of it. Let's come over here. So when we go to do our division, this guy, what we divide by, goes outside of the division house, and what we're dividing into goes inside of the division house. We got cosine on the outside. Cosine is even. So as an even function, the very first even term is 1. Why is that true? Because it's multiplied times x to the 0 power, and that 0 is an even number most of the time, all the time. All right, now it alternates minus. Next even term, x squared over 2 factorial. I didn't leave myself any room to actually do this division. Let's scooch down. Okay, that's good. Next one is a plus x to the 4th over 4 factorial. And I probably won't need it, but just for fun, x to the 6th over 6 factorial, and then plus stuff. Divided into, maybe this division house isn't quite big enough. It needs to be bigger. There we go. And the first odd term for sine is just x, because it's x to the first, right? Okay. Alternate minus x to the 3rd over 3 factorial plus x to the 5th over 5 factorial. That's a factorial symbol, can you tell? Probably not. I'll fix it, no worries. Minus x to the 7 over 7 factorial. Not that we need that term. I just wanted to do it. Okay. Now, whenever you go to do this long division here, you ask yourself, hey, self, what do you have to multiply 1 by to get x? It's pretty much x. Now what do? You take this x and you multiply it times all of this stuff here. Big old distributive property. So x times 1, pretty much x. And then you got to make sure that you line up your terms with the correct degrees, right? Okay, so now x times x squared is going to make that x cubed, negative x cubed over 2 factorial. And you know what I just realized? Like, I don't want to deal with all of these little factorials. Let's fix them. So 2 factorial is a 2. All right, why do you keep going back to laser pointer? 4 factorial, I think, is a 24. 6 factorial, see, it's 24 times 6. That is another 24. Carry a 2. That's a 12. It's 144, 24 times. That isn't true. That is not what 6 factorial is, because 6 factorial is 6 times 5 factorial, which is 120. Whoa, 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 whoa. Almost made a fatal error. Okay, so 0, 6, 2 is 12, 1, that's 720. Of course it's 720. Everybody knows that. 6 factorial, 720. Delete. All right, let's fix these over here. 3 factorial, 3 times 2, that's 6. 5 factorial, 120. Already did it. 7 I'm leaving that one. Anyway, where was I? Oh yeah, we had already multiplied this x times x squared over 2 and got x cubed over 3, which magically lines up with this one. That's very nifty, and it is also minus x cubed over 3. If it had been an x squared, Then we would have had to scooch these terms over to make room for it, because you got to line these things up for when you subtract. All right, keep going, keep going. Now I got to multiply this x times x to the 4th over 24, add our exponents, x to the 5th. Ooh, look at that, matches up again. So plus x to the 5th over 24 this time. And then you can multiply the next one if you want to. I'm not gonna, unless I need to. I don't know. I'm just gonna have to wait and see. So now I got to subtract. Go to red, subtract. So when I subtract, I'm going to change all the signs. This red subtraction sign is going to override that +1, that blue plus. We know this. Okay. So subtract here, x minus x. Those things are going to go away by design. Boop. And now I'm going to, let's see, I got -1/6. Stop like randomly zooming out. Plus a 1/3. Common denominator there is a 6. That's easy enough. Okay, right. No, that's not even supposed to be a third. Haven't you been paying attention? That's a 2 down here in the bottom. There we go. Now we're adding a half to it. Okay, anyway, so that half that still has a common denominator of 6, which would be a 3. Subtract that, gives us a 2 over 6, which is a third. So x to the 3rd over 3. Delete this stuff. All right, and then I am subtracting 1 over 120 minus 1 over 24. Oh my God. 1 over 120 minus 1 over 24. This is going to be fun. Actually, it's not bad at all. The reason why it's not bad at all is because common denominator is going to be 120. I know that because 120 over here is 5 factorial, which is equal to 5 times 4 factorial, and 4 factorial is what 24 is. So all I got to do, folks, is just multiply that by a 5, multiply this by a 5, there we go. So up top I'm going to have a -4, looks like. -4 over 120, reduce it. 4 goes into 120 exactly 30 times, so -1 over 30, so negative x to the 5th over 30. Do the next one if you want to. Okay, now you ask yourself once again, hey self, what do you have to multiply 1 by to get x cubed over 3? And it's going to be plus x cubed over 3. Nice. Now do some multiplication here. So x cubed over 3 times 1 is an x cubed over 3. X cubed over 3, multiplying that times x squared over 2, so it's going to be negative. X to the 5th when we add our exponents over 6. Negative x to the 5th over 6. And if you want to, multiply the next one. You're going to see why in a second why I won't actually need that. Remember, we're only needing 3 non-zero terms, and we've got 2 of them. Next up, subtraction minus plus. These terms, they just disappear? Why, of course they just disappear. And now we just have to do our subtraction over here. -1 over 30 plus 1 over 6. Another easy one, because all I got to do is multiply by 5. So that's 5 over 30. 4 over 30 positive, which reduces by 2. 2 over 15. So positive, right? Yes, 2x to the 5th over 15. You have stuff over here that I keep forgetting to add. Okay. Or maybe I'm ignoring it on purpose. So you ask yourself one last time, what do you have to multiply 1 by to get 2x to the 5th over 15? It's pretty much plus 2x to the 5th over 15 plus yada, 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 and you're done because you have now your first 3 non-zero terms for tangent. And that's how you do it.